Mr. Ahmed here. Last section here for chapter 8, 8.4, involves us setting up proportions using parts of a triangle. So we're going to go over one special case, and the one special case we have involves a segment being parallel to one of the sides of a triangle. So in this example here, where we set up our first proportion, xy is parallel to rs. So since those two sides are parallel, obviously xy is not parallel to the other two sides. It divides those two sides proportionally. So I rewrote this as rx to be a, just so it's easier to see. Xt is b. So I would say a over b is equal to, looking at the other side, c corresponds with a, that's closer to the bigger piece, so c over d. A over b equals c over d. So when I look at some examples here for us to actually solve, we're just going to set up the same exact way. So here I see we have a triangle and a parallel piece cutting the triangle into some parts. So when I set up my proportion, these two sides are divided proportionally. So 20 over x is equal to 18 over 9. And then we could cross multiply to solve. 20 times 9 is 180. Equals 18x. X is equal to 10. And just one more example for this. In this case, again, parallel to one of the sides. So the other two sides are divided proportionally. So I'm going to start over here. 18 over 6 is equal to, 18 corresponds with the x plus 22 over x plus 2. Now this one's a little bit longer. When we cross multiply, we're going to have to distribute. So we have 18 times x plus 2 is equal to 6 times x plus 22. So 18x plus 36 is equal to 6x plus 132. And combine our like terms. I'm going to subtract 6x to get 12x equals subtract 36, 96. Divide by 12, and x is equal to 8. So that wraps up our section on chapter 8 with proportions. Have a great rest of the day.